Hey guys, I'm Matheus Castello, embedded software developer, and today I want to show you how debug Qt applications using Visual Studio Code, okay? And with debug helpers, okay? Showing the values of complex Qt types like we have on Qt Creator, okay? If you want to know more, stay with me. Okay, so let's do it then. The content of this video is also a blog post. I will leave the link here on the video description, okay? And I would like to start by remembering you from the last video about the Qt creator with debug helpers not working, okay? So we will use the same project from the last video. The video will be shown here on the cards, also link on the video description, okay? So we will use the same project, but we will open on the Visual Studio Code, okay? So let's do it then. Let me open here the blog post that is the name of the project that we give on the last video. So you can see that we have some errors here because Visual Studio Code does not know about the location of the include paths, okay, the include paths. So it's there is some errors here about cannot open the source file for the header, okay? We will fix it, but first we need to have the C and C++ extension installed. So I already have it here, so you have to make sure to have it installed on your Visual Studio Code, okay? So with this we can continue, and the first step is add a launch to our project or workspace here, because on the Visual Studio Code we call the folder that we have the projects the workspace, okay? So let's configure this workspace to be able to run and debug our application, okay? So let me type here F1. So this will open this command palette here. So let's put C++, yeah, add debug configuration, this one that we need here, okay? Maybe it's a bit, let me put a bit more zoom here, okay? So let's do it again. Yeah, this option here, you can start by typing C++ and then you can search by the add debug configuration. So let's choose this one, and then we have these options. So let's choose here the GDB launch, this one, because we use the GDB to run and attach to the debugger, right? The GDB will be our debugger for our Qt application. So let's select it, and then this will create here this launch JSON file, okay? That's located here on the workspace .vascode folder launch JSON, okay? So this file has the configurations that Visual Studio Code needs to know how to launch and who will be the debugger for this launch, okay? So let's rename here. Let's rename for Qt app, okay? Yeah, the type is CPP debugger launch. This property here is very important, right? The program, okay? Because here we need to put the path for the binary already compiled with the debug symbols for our application, right? So I'm using here the same project from the latest video, and we know that Qt put the folders of builds not in the same folder from the source code. Okay, so I have here my source code. This blue here is very bad with the same blue background from my screen, my wallpaper screen, but no problem. Let's continue. You can see that I have here the blog post that is the folder that I have my source code, but also Qt Creator creates this build project name, the version of Qt, okay, debug. So I know that my binary was compiled and stored on this folder. So is this folder that I will put it there. You can see that we have here not blog, the blog post. Okay, oops. Build blog post, this one. You can see that we have the binary here. It's a simple console, Qt console application. So let's add this there on the Visual Studio Code program property. So you can see here that there is a tip, enter the program here. So yeah, let's put it here. Oops. Oh, this does not get my, I have to copy. Okay, yeah. All right, paste it. Oh, now, and the binary is called blog post. All right, but also here on the launch JSON of Visual Studio Code, we can use some environment variables or some variables that, for example, if I put workspace folder here, the Visual Studio Code will know that the workspace folder is this folder here, right? The blog post, the folder that has the source code. So we know that we have to back one folder, and then we will have our build blog post, blah blah blah, debug, and the binary. Okay, so is it this? This is what we need. The program property here, right? The program property is really the property that we have to edit to put the path for the binary compiled with the debug symbols. With this done, yeah, we still have the problem with the headers, but this is also very easy to fix. Okay, so let's configure it. You can mouse over here at the line of the error and click quick fix, and then add to include path. Okay, so this will open this tab, C and C++ configuration. So you can search here by include path, this one. You can search by this section, okay? And you can see that we have two lines here. One line that is including everything from workspace. So if we have some header here on the workspace on this folder, this will be automatically added as an include path for our project. And also by the option that we choose it when we click it on quick fix, it added this user include, but sometimes this does not work as expected. So it's better to add the user include everything. Okay, so this way we will have all the headers from the system included on our include path. Okay, so I have to give to you more one tip about this text box here, because it's a bit weird the way that it saves the data. Because let's put another thing here. So for example, let me put user, only user, okay? And I go back to main CPP, and maybe you are thinking, okay, I add one more line there and it's automatically saved, okay? But if we back to C and C++ tab, you can see that we can back to the include path and it's not there, okay? So make sure that when you add something here, you click out of the test box, okay? Because this way is the way that this will be saved, right? The data that I put it now is saved. So I can back to the main.cpp, back to C and C++ configurations, and our user is there, okay? But if I remove it, back here, nothing happens. The data was not saved. So make sure to edit the text box and click out of the text box to data. So this way the data will be saved. Okay, cool. So now we have Visual Studio Code configured to our Qt project. Okay, we have all the headers here on the include path. We can have the IntelliSense for Qt types, for example, with some tips. For example, let's put here the Qt process environment, control space, and I will have alt methods, alt static methods with tips about the headers of the methods. So yeah, very cool. Now the Visual Studio Code knows the include paths and also give me out IntelliSense and tips for my development, okay? But, and about the debugging, right? Let's put a breakpoint here. We already configured our launch.json, and then it's simply press F5 because we only have one entry or Qt app, okay? So we can simply put the breakpoint and press F5. Okay, so you can see that these byte configurations that we put on launch.json, this called the GDB and called the program that we put on the program property. Okay, it's already running. We have the debug console here, so we can check and evaluate all the local variables here. So let's press F10 to go to the next line. So here I'm doing the same that we did on the last video. Okay, so I'm getting the environment variable pwd, okay, and storing at path. So let's go, and you can see here that our Q string has something weird, okay? It's more or less the same issue that we had on Qt Creator. You remember about the debug helpers, the GDB Python scripts that we had to solve from the latest video. So now we have something very similar here. If I try to evaluate Qt complex types, this will show these weird addresses. Here you can see that this solved this string, okay, but I had to enter on the type. For other Qt types, maybe we will have not the same lucky to have this, okay? So we need to also here on Visual Studio Code configure the pretty printers, the debug helpers, to have this nice and user-friendly way to show the values of Qt complex types. So what we can do to solve this issue? Okay, so we need the Python scripts, okay, to have the pretty printer to show the values in a user-friendly way here on Visual Studio Code, and we use the GDB init, okay? But unfortunately, we can't use the same Python scripts from the Qt debug helpers, because the way that Qt creator injects and uses these Python scripts is very different, and that's the way that Visual Studio Code is expecting. Okay, so for our lucky, okay, we have the kdevelop, right? That is the IDE from the KDE guys from the KDE community. All right, and maybe you know that the KDE uses Qt to develop their graphical user interface. Is all based on Qt. Okay, so they already solved it for kdevelop. They wrote some Python scripts for GDB to work on GDB init, okay, to make these debug helpers for kdevelop. And we use the same scripts here to have it on our Visual Studio Code. Okay, so here on the blog post, I will follow here the same instructions. So we need to go to home. Okay, so let me go here to my home. After that, I need to create this folder .qtpp, that means Qt pretty printers. Okay, so let's go inside this folder, and then we will download the Python scripts from the GitHub from KDE kdevelop. Okay, so we need this helper py, okay, and also the Qt py. Done. Okay, first step done. Now we need to edit or create the GDB init. Okay, here on my case, I will need to create the file. Okay, and on this file, we need to put this content here. Okay, so we are telling to the GDB to use Python here, and inside this block, the Python script you run first, adding our home qtpp or home.qtpp to the path. Okay, so Python knows where our Qt py and helper py is stored, and then we can use them to register the Qt pretty printers. Okay, it's simply that, because GDB, you seek for this .gdb init at the root of your user home, okay, and then you load this GDB init. Every time that you call GDB, this will be executed. Okay, so we will have the Qt pretty printers loaded and registered. Okay, so with this done, we can back here to our main CPP and simply press F5. So now we can go to our Q string. This you get the pwd environment variable you will store on the path, and now you can see that we have the pretty printer working. So now we don't have all that complex structure. We only have the value of our Q string. Okay, that is our pwd path. Okay, you can see also here on local variables the pretty printer works. Okay, so nice, we did it, right? We have the Visual Studio Code working with debugging, with debug helpers, showing the Qt variables values and etc. But let's say that you have an Qt application for embedded systems, for embedded Linux, and we want to use Visual Studio Code for this remote debugging. Okay, so all the configuration that we did for make it work, you should also do on the remote target, right? You had to configure it on the remote environment, right? So what I want to show is that toradex has this cool Torizon Apollo X extension here on Visual Studio Code, this one, okay? I already have it installed here on my Visual Studio Code, and when you install it, it comes with these two new buttons here on the Explorer: New Torizon Project and New Torizon Multi-Container Project. So the cool thing is that this comes with a cool template for Qt 6 KML application, right? So all the configurations that we did here for download the pretty printers from kdevelop, configure the.gdb init and everything, remote deploy and attach to remote debugger is all configured on this template. So let's simple create a new project. Let me put here blog post. Oops, blog post. Yeah, something that I had to mention is that we have the name of the project and also the Docker Compose service name that should be created, because all this configuration will be deployed on the target through containers, right? So it's like we are shipping out the debug environment configured through this package, this container, right? So let's put also here blog dash post. This will be the name of our Docker Compose service, and I will start a new project on my temp VS Code. Okay, so now the extension you create my project based on the template of Qt 6. Okay, all right. You can see that we have the main CPP. Do you want to check for dependencies? Yes, let me check for dependencies. I think that I already have everything. Yeah, our package is already installed. It was something about QML here, but I ignored it. Okay. Oh, there is a problem here. No instance of. Oh, okay, I know what is this. Is an issue here on the template on the CPP properties. You can see here that the CPP standard is GNU++ 14 and should be 17. Okay, save it, and yeah, issue fix it. I have to open an issue to not forget about it and fix this. But yeah, let's continue here. We have our main CPP. We have the QML, main QML, the scene, YQML, some assets for our QML, out Docker Compose, Docker files. So as I said, here on the Docker file debug is the recipe for configure our development or debug environment, okay? And you can see here that on the recipe we have some commands to configure or get the Qt pretty printers and also configure the GDB init. Okay, so this will be shipped. You do not need to mess up with this. If you have the device here, I have my Raspberry Pi here. So this one, Raspberry Pi 4, with the common Torizon installed, and yeah, you can use Torizon in non-toradex hardware. Okay, using the common Torizon. I will leave link here on this video description. And you can see here that I'm using it as target because I have the averding registered. Yeah, I have these two devices connected, but the target is this one with the icon of target, right? So here I can set the default device, right? And this device that is the default, you'll be used as a target for our remote deploy and remote debugging. Okay, so with this we can add some breakpoints, but before, let's edit a bit this here, because I don't want to only print some hello world. I want to show also to you guys that, oh yeah, this application is running on the remote target. So you use the QSys info, yeah, this one. And so let's use a Q string to check if the pretty printers for Q types will be working. So we can get from QSys info the CPU, yeah, current CPU architecture. Okay, so this will return a Q string. Yeah, we will store it here on arc, and instead of hello world we will print or see out here the arc to as standard string, yeah, to std string. All right, all done. Okay, we are using here the std cout instead of qdebug, but I will tell why. All right, it's because as you remote debug this one, VS Code will not get the redirect of the terminal, but only the console of the GDB. Okay, so the qdebug you'll be sent to standard output instead of the debug console. So because of it, we are using the std cout for now. Okay, but yeah, this is a detail, and so let's put a breakpoint here. All right, and let's start it. Okay, so let's click here on run and debug and choose the architecture of our target. Okay, so is a Raspberry Pi running Torizon 64-bit, so Torizon ARM V8. Okay, and then I can click here on the play or press F5. Let's press F5. So now the extension, you do all the work for me. You cross-compile the application. You create the Docker image for me with all this stuff configured, all the Qt printers from kdevelop, the GDB init, everything. So all the debug environment will be shipped on the remote target for us automatically, and at the end, the extension will run the GDB on the remote target, and you attach to this remote GDB running on the board. So let's wait a bit, because it's a lot of stuff that is happening here behind the scenes. Okay, so it's done. All the build was done successfully, and we have the debug attached. Yeah, the remote debugger is attached. We have our breakpoint reached. We have here arc, that's nothing, right? So we will get the CPU architecture. Let's go to the next line. Yeah, now we have ARM 64-bit, all right? Exactly the value that we are expecting. Show it in a user-friendly way using the Qt kdevelop ready printers on the remote target, right? On my Raspberry Pi here running Torizon, right? Yeah, we can continue its execution here. You can see it, ARM64 here on the debug console, and we can continue its execution, and then yeah, the window will be shown there with this animation and Torizon logo, right? one thing, the last thing that I had to show you, see that was very easy, right? But it's take a bit, it takes some time to build everything, to get out the packages, to build everything. But I will prove to you that is only the first time that you do it. After that, this will use the container cache. So for example, if you add here arc, and we will compile it again and run it again. Now it's saved the last debug targets that I choose it. That is Torizon RMV8, and you deploy it for Torizon RMV8. So yeah, let's wait here. But yeah, what I want to show is that the second time that you compile it and run out the containers and build everything, you'll be much more faster because this will use out the cache. Yeah, you can see it. It's pushing, it's checking. Yeah, just already pull it, right? You'll be using the cache already created, starting, compiling, and waiting, attach it. Okay, yeah, you can see that now this will be this happens much more faster, right? We have it here, the arc ARM64 as expected on our debug console with everything configured. Debug, the pretty printers for GDB here running on the remote target inside the container and everything. So yeah guys, I think that is it that I want to show to you today. So I show a bunch of stuff for you, right? From using it with already Qt Creator project, configuring it manually, and also using this cool template from Torizon, from toradex, that have everything configured to you, and you can remote deploy and remote debug. So yeah, if you like this content, don't forget to subscribe to the channel, right? Follow me on the social media. All the links for my social medias here also on the video description. All right, so I think that's it, and see you on the next video.